To cut a very even circle on the 22-inch square piece of 3/4 inch plywood, I used a technique that was described in a YouTube video from Dan Rojas of greenpowerscience.com. You drill a hole in your saw table opposite where your motor is. In this case, I drilled a hole that was 9 inches away from the blade, from the outer portion of the blade, and that gave me an 18-inch diameter circle. You take a 1/4 20 bolt, is what I used in this case, and I centered this hole on the piece of plywood by drawing diagonal lines, and then I rotated the wood, and I slowly raised the blade on the machine just a slight amount each time, rotating at 360 degrees. And it took a while, but eventually the blade came through, and you can see here, the interesting thing is you can see the shape of the wood here. See a different angle right here. You can see it's slanted, which is expected when you think about it, when you think about that flat blade cutting on an angle, but it's actually what I wanted anyways, so that the material, when it's stretched over, won't touch the wood. It'll have a nice sharp crisp edge on the circle portion of it. The actual opening of the parabolic just ended up being just slightly over 18 inches, which is perfect. It's what I was shooting for. The material I'm using is 24 inches wide, so there'll be about a 1.5 inch overlap on each side to help tuck it and make it sealed. I'm next going to glue sections of 3/4 inch plywood that is about 1 7/8 inch long along the edge below the sanded side of the plywood. This is going to form a box, and then there's going to be another layer of the 3/4 inch plywood on the bottom of it to seal it off. Here's what it looks like after I assembled it. I used a brad nailer about every inch, and I used a high quality carpenter glue, and any imperfections you want to put a wood filler on them, on the brad holes and anywhere there might be an imperfection, and then I lightly sanded it, rounded off the corners best I can, and then I'm putting multiple layers of filler to get it as smooth as I can. And then I'm going to finish it off with a water-based urethane to give it a final glossy filling. So this is what the final product looks like in terms of the finish. I have 3 coats of water-based urethane on here, and it's sanded in between each coat, and a final light sanding and polishing. It's kind of at a furniture grade level of flatness, and finish, as you can see. To allow access to create a vacuum for the parabolic, I cut out a circular hole of a diameter of 2 1/4 inches, and I'm using 4 1/4 20 bolts with T-nuts to secure a wooden plate. I'll show you right here. As you can see, the 1/4 20 bolts on there. This wood is going to have a rubber piece on there, 1/32 of an inch, as well as this to form a very airtight seal. And in the center there is a small hole which I'm going to mount a one-way vacuum check valve, which will allow me to create a vacuum inside the chamber, the box, and it will hold that vacuum for me. Those T-nuts are just 1/4 inch T-nuts, which you can get anywhere, and the bolts are just 1/4 20 2-inch long, 1/4 20 stove bolts are called. So by tightening the 4 bolts down with a rubber seal here, you should be able to get a really tight seal. I'm going to be making 4 legs for this parabolic mirror. These are made out of 1.5 inch PVC sections. They have a thread on one end and a gluable section on the other. This thread is nice because you could adjust 2 of these corners so that you can get the parabolic mirror flat on the ground. And the other ones are just 1.5 inch PVC that painted black, and the ends have 1/32 inch rubber glued onto them. So I'm going to be adjusting the height of these with some additional PVC and gluing in the corner and screwing in end caps that I can push the PVC sections into. I mounted the PVC legs with the rubber ends. 2 sides are the same height and 2 other sides are the same, but they've got that adjustable section on there so that I can change the angle of the whole parabolic so that it's parallel to the ground. Here's the way it looks after I added the 1/32 inch rubber to the 4 holes for the carriage bolts and the opening. And the cover here also has rubber on there through the holes, and even the bolts themselves I put rubber, and I added additional 1/4 inch washer on each one. So this will improve the seal. I received the package from Carnival Mirrors today, and it's a very interesting material. It's relatively thin, somewhat rigid, so I very carefully cut it. It couldn't be bent over like you'd wrap a package. So what I did is I cut it right to this edge right here, all the way around, and then I used duct aluminum tape very carefully, and I stretched it as tight as I can all the way around. I put 2 pieces, one piece about 1 inch over the edge, then a 1/2 inch offset from that all the way down. So it looks pretty good, pretty flat. Not perfect, but I haven't tried any vacuuming of the air at this point. But it looks like it worked out pretty good. So it's not the silvered side shown. The silvered side is on the bottom. This is the typical mirrored side. I'm not going to worry about double reflections. I wanted to have a surface that was more durable. Since it's such a thin material anyways, we're not going to get too much of a diffraction problem. To reflect the image from the parabolic mirror, I attached a front silvered mirror at a 45-degree angle, put a counterbalance on there, and put it on a tripod with a 1/4 20 bolt mount. After doing some experimentation on the parabolic mirror, I thought the parabolic mirror had to be in a horizontal position to be accurate enough, And after doing some testing with this mirror and also putting it vertical, it seems like I don't need to have a mirror like this, which just makes something else I have to realign. So I'm going to make a new mount for the parabolic mirror so it could be held up vertically on this tripod and eliminate this 45-degree front silver mirror in the design. I also added 1.5 inch section of gaffer's tape all around to help remove reflections in the corner and also to give a little more sealing ability to the vacuum that's being created. To create the vacuum pressure, I purchased on eBay a Thomas vacuum pressure pump, model D-82178. It's made in Germany. It was a perfect amount of vacuum force that I needed. It's kind of a small to medium size pump, and it's a DC 24 volt pump that I'm running with a 18.5 volt 3.5 amp laptop power supply that I had. Ended up being the right voltage, a little bit lower than required, but a little less pressure, which is fine. And I've got one of these quick disconnects vacuums on there, and goes off to a T connection where one end has one of those fish tank, I guess, regulators, so that I can regulate the amount of vacuum. If I totally open that up, the vacuum will be lost. If I close it down, I can go to full vacuum. And to hold that vacuum in place, I have a one-way valve which I got on eBay. I'm going to demonstrate how it works. I'm going to turn on the pump. See, the pump is going right now with about 18 volts DC going to it. So right now it looks like a flat mirror, and once the pressure starts building up, it's going to start vacuuming out all the air from the back connection here. And you'll start to see it's forming a parabola. It's probably hard to see, but you can see the circle there, and you can see my reflection, normal reflection like a normal mirror, and then you can see my reflection going away and going to a magnified section here. So if I go back here, you can see it's forming a nice parabola with a focusing point of about 6.5 feet and a focal length of about 3 feet, a little over 3 feet. I'm going to talk a little bit about the light source I'm using for the schlieren photography system. This is a LED flashlight. It is a Ultrafire WF502B. And I modified it so that I could put some DC power to it, 3.7 volts to match the lithium-ion battery. And I ground down a little bit of the top aluminum. And to power this, you can get these little DC modules on eBay that convert 12 volts to 3.7 volts. And so I have a 12 volt input going to that, and then it's converted to 3.7 volts. I have some connectors on the end of that that's used in the RC industry. Allow me to disconnect or connect the battery. The switch is still functional. I can turn it on and off also. To get the light to the schlieren rail that I made, I'm using a optical fiber from Audio System. These are pretty common. It has a little extender piece on the end there, and I made a circular cap that fits over the LED, and then the output of this goes to the rail. So that's the flashlight with the cap on there, and that fiber tube is just about right on the LED inside there. I didn't grind down the LED, it wasn't necessary. You can see little 1/8 inch holes. That's just for heat to escape the system. Here's the rail that I made. It has the fiber optic opposite end coming in, and it's on an aluminum section that's on a sliding rail. The rail is made out of laminated particle board that's been polished and with paste wax put on there. And I tapped in some screws on both sides so that I can rotate the light 360 degrees if I have to, but it only needs a slight rotation. You want this light to shine into the center of the parabolic mirror. So that allows the adjustment. You'd also change this moving forward and back, which changes the focal point of the light into the lens of the camera. As you can see, I'm using two cameras here. I have a paraspectrum camera that's mounted on the top flash rail of a Canon 550D T2i with a Canon 50mm lens. I think it's the f1.8 lens. I have the display turned off and I have an HDMI cable running across over to a monitor. So this allows me to see full spectrum images of the mirror, and then this camera is picking up the schlieren or the so here's a parabolic mirror. It's not parabolic at this point. It's just a regular flexible carnival mirror, and now I'm going to turn on the pump. You can actually see the image changing here on the monitor. You can see it's going from a flat mirror to a parabolic. You can see it here also. So this is the front view of the setup, where you can see the wooden custom rail with the light I talked about on the sliding rail, with the Canon T2i and a paraspectrum camera from Modotronic. Here you can see the light source. See, it's very tiny. And one thing that's unique about this is to help you line it up, I made an end piece that allows you to have the light much brighter, much higher diameter for alignment reasons, and then you put on the cover, which has a pinhole on there for the correct amount of light for the schlieren system.